JJ Math.
This chapter on exponents ends with surds. So surds is just a big word for roots. You've been used to square roots and cube roots, but surds refers to any root. But it is a specific type of sum, and it has specific methods that you need to follow whenever you have a surd question. Let's look at what I mean. So if you see 48 and the square root of 48, it's very easy to just type it in your calculator. So the calculator will tell you the answer is 4 root 3. So the teacher is going to want a step between the calculator's answer and your answer. So my advice would be to use the calculator, but give yourself an extra line. So the answer is 4 root 3, but your teacher is going to mark the step in between. So I need to figure out what that is going to be. Now the tip is to always look for the biggest square number that can divide into, in this case, 48. And the biggest square number is 16. So I can rewrite this as 16 times 3. But if you struggle with that, just take the calculator's answer and square the number in front of the root. So 4 squared is 16, and that's why I can just write it as 16 times 3, and then I will get that mark and that mark. If you just use the calculator, you will maybe get the last mark, but some teachers will just not mark it and say you didn't work it out yourself. The next one, square root of 128. So let's not use the calculator for this one. So let's think, what is the biggest square number that can divide into 128? So let's just go down the list of square numbers, and I would advise you to do this as well if you are not going to use the calculator in the exam. So I know 2 squared, 3 squared, 4 squared. Okay, that's still too low. So I can go 6 squared, 7 squared, 8 squared, and then 9 squared is getting too close to the number, so it's definitely not 81. And in this case, 64 times 2 will give me the answer. So I can rewrite that as 64 times 2. I know the square root of 64 is 8 root 2, and that is exactly what the calculator will tell me if I type that in. Now we get to sums where they combine 3 or 4 surds into one equation. Let's look at the steps you're going to follow. So you're going to rewrite each one of those 4, just like I just showed you, and then you are going to simplify it, and then you're going to look for a common factor, take it out, and then cancel and simplify. So let's look at how we would do this sum. So I'm just going to do it up there. And 80, I now need to think what's the biggest square number that can go into 80. If I look at this list I used previously, I can see 25 might go in there, but 25 times 4 is 100, so it's not that one. 36, 49, they don't go into 80, but 16 actually goes into 80. So this will be 16 times 5. Like I say, if you get stuck, use the calculator. The calculator will say it's 4 root 5. Then just square the number in front. Okay, 48 we luckily just did. So I can say that is 16 times 3. Then the 20 will be 4 times 5. And the 12 will be 4 times 3. Okay. So in that step is where I'm going to get all my marks, because the teacher knows you can't do that on the calculator. The next step is I'm just going to write down the calculator's answers if I used the calculator. But that won't count as many marks as the previous step. Let's see how it looks. So 4 root 5 minus 4 root 3. So because the 16 is a square number, I can get the square root of 16, write it in front, but the other number, the 5 or the 3, is not a square number, so that needs to stay inside. The same with the 4 at the bottom. Square root of 4 is 2. The 5 stays in there, and the 3 stays in there. Now, like I said, you are going to take out a common factor. So at the top, the common factor is the 4. And what is left there, root 5 minus root 3. At the bottom, the common factor is the 2. And what's left is root 5 minus root 3. Now you will see the brackets are actually identical, so they can cancel out. And 4 divided by 2 is just 2, and that is the answer to the sum. So let's just check where the marks would be. So if this counts 4 marks, you are going to get a mark for that one, for that one. I would think this next step wouldn't even count a mark. So you would rather get a mark for taking out a common factor and cancelling, and then for the final answer. So watch out to not skip the second step, because that's the most marks. Now we're getting to a new concept that is only present in grade 11. It doesn't really come up too much in other places in maths. But it's called rationalizing the denominator. So if you want to do a little experiment, please type in your calculator 4 over square root of 3 and just press equal. You will see the calculator automatically changes the value even though you didn't plus, minus, multiply, or divide by anything. The calculator rationalized the answer. So just like if you type in negative exponents, the calculator is forced to give you a positive exponent. So there's certain rules in math that always applies. And one of them is you are not allowed to have a square root in the denominator and leave it like that. So your final answer can never have a square root in the denominator. How do you get past it? So very easy. I am going to multiply this fraction by 1. And 1 can be anything. So in this case, I want 1 to be square root of 3 over square root of 3. And the final answer to this sum would then be 4 square root 3 over 3, and I trust that that is what the calculator also told you. Okay. Now with the next one, you will now see a cube root. So when it's a cube root, I'm going to times by 1 and times by 1 again. What that means, or how that looks, is like that. Cube root 5 times cube root 5. So whatever the exponent of the root, you call it the index of the root, whatever that number is, so if it's a square, you multiply it twice. If it's a cubed, there must be 3. Sorry, you don't multiply it twice, there must be 2 root 3's to cancel each other out. So if it's a cube root, then I'm going to have three terms that I'm multiplying in order to cancel the root. So in this case, the final answer would be 4 cube root 5 squared, and then at the bottom, it's just going to be 5. And that would be my final answer. So in the previous sums, we did rationalizing the denominator, and I just multiplied by the denominator at the top and the bottom. But now, if it is a binomial, it works a little bit differently. So I am going to multiply this again by 1, but in this case, 1 is going to be the denominator, but with the opposite sign. If you study AP Math, you call that the conjugate, but in normal pure math, you don't need to know that. So just going to multiply top and bottom by the denominator, but with the opposite sign. So what that's going to do is at the top, I'm just going to have to multiply in the 4, but at the bottom, it's actually going to be distributing in, and it's going to be like difference of 2 squares. So it's a bracket with a minus and a bracket with a plus. So just because it's the first one, I'm just going to write out everything that I do. So 3 times 4 plus 4 root 5 at the top. And then at the bottom, it's going to be 3 times 3 plus 3 root 5 minus 3 root 5 minus root 5 root 5. Okay, so like I say, you don't need to show all these steps every time. You can do it much quicker, but just so you know where these things are coming from. So at the top, I am going to have 12 plus 4 root 5. And at the bottom, 3 times 3 is 9. And then these two terms are actually going to cancel each other out. One is a plus, one is a minus, so therefore they just cancel out, and I am left with root 5 times root 5 is just 5. So at the bottom I now see 9 minus 5, so that's a 4, but then you must always check, is there maybe a possibility to take out a common factor at the top? That is maybe a 4, and that's exactly what happens in the sum. So I can take out a 4, that is 3 plus root 5, and at the bottom that's a 4, so the 4's cancel, and my final answer is just 3 plus root 5. Okay, final question. In this case, I am going to combine the previous two sums. So the first one is a binomial in the denominator, so I'm going to multiply by the same denominator but with the opposite sign. And then the second term, I'm just going to multiply by root 3 over root 3. So in this case, let's see how it looks. So I'm going to multiply by root 3 plus 1 in a bracket, and then root 3 plus 1. The next one, I am going to just multiply by root 3 over root 3. And simplify. So I'm going to distribute the root 3 in there, so that will just be 3 plus root 3. At the bottom, this is now again that difference of squares brackets. But just like the previous one, the middle two terms are going to cancel out. So I don't need to write all of that again. I can just say root 3 times root 3 is 3. Minus 1 plus 1 is just minus 1. And then the one to the right will just be 2 root 3 over 3. And my final answer would then be, well, not the final answer yet. I just need to see if I can write it a bit simpler. So now I can just say this is a 2, this is a 3. So if I LCD there, this would be a 6. And I'm going to have to multiply this by a 3, and I'm going to have to multiply this by a 2 to just leave it in simplest form. So this would be 9 plus 3 root 3 minus 4 root 3, and the final answer in this case would then be 9 minus root 3 over 6. Okay, so you made it to the end of the exponents chapter for grade 11. Please go and do all the exercise videos as well to just make sure you can practice and you can see how difficult this actually gets. And then at the end, please try the exam level questions to see if you're ready for your exams.
If this video helped you, please like and subscribe.
JJ Math.